This is our final section in Chapter 7, and now we're going to take all the things that we've learned and put it together in solving equations. So what that means is you're going to see an equal sign now, and you're going to be working on both sides to find out what x has to be. Okay, wow, this is really pink. Sorry about that. It looks like somebody threw up Pepto-Bismol on here. Okay, so I'll try to get over that. So what I'm going to do is do an example on each page, and then I'm going to have you do the one that's at the bottom for the pause and play, and then check yourself when you're ready. All right, so what happens here is I have two fractions set equal to each other. So just like we've always done in math, in that case, we can just cross multiply. So what we're going to do is cross multiply here. So we have 3 times 4x plus 5, and then we're going to set that equal to 9 times x plus 1, and we're just going to simply solve that like algebra 1 rules. So we're going to distribute, distribute, and then get my x's on one side, and I certainly hope I'm not doing anything new here. You should already know this. I'm going to subtract 15, so I have 3x equals -6. So x is -2. The only thing you have to be careful about here, guys, is making sure that the answer you get doesn't give you a 0 in the denominator on either side. And so I'm putting this back in going, oh, no, that's -1, and this one is -3. So that's fine, as long as it doesn't give you 0. If it does give you 0, your answer would be no solution. Okay, so now I'd like for you to pause the video, try this problem at the bottom, and then play it when you're ready to go over the answer. You can pause now. All right, so what hopefully you have on your paper is this. That's the cross multiplying step. So we'd have 6x plus 4 is equal to 10x plus 20. Your next step should be -10 subtracted. So that would be -4x. Ooh, this color is going to get bad. Subtract 4, so that's 16. So your final answer for this one, guys, should be x equals -4. Again, I just want to double check and make sure, and it does not give me a 0 in either denominator. In the last question, we had two fractions set equal to each other, which means that we could cross multiply. In this case, we have two things being added together before they're set equal to the other side, which means I have to cancel out the denominator. So I don't want that denominator on the bottom. So what I do is I take the common denominator, which I know some of you are still working on trying to figure out. In this, you want a combination of everything. So I'm going to use 4x as my common denominator. What I'm going to do is multiply that common denominator by each individual fraction. And what that's going to do is cancel out my denominators, which I don't want in the first place. So I'm going to take this x is going to cancel with that x, so that leaves me with 20. This 4 cancels with that 4, so that leaves me with 7x. And on the other side, this x cancels with that x, and I'm left with -36. So what I've done is I've made this problem way easier by just canceling out the denominators. Now I can solve this with no problem. And that would give me -8. And you just want to, again, go back up to the top and just make sure that it doesn't give you a negative in the denominator. I'm sorry, a 0 in the denominator, which it doesn't. And now you can pause the video and come back when you're ready to watch the solution. All right, I'm going to multiply all three of these by 2x. So that's going to give me 6 plus 5x equals -24. What's that? -30. Therefore, x is -6, and that looks like it's okay because it won't give me a 0 in the denominator. Obviously, this is your last and final example because it ends in F for Jeff. Oh, okay, so what I need to do in this case is exactly what we did in the last one, except our denominator is going to be larger. So the first thing I want to do is figure out that common denominator, which means I have to get the factors of everything. So I'm going to take this x squared minus 9 and factor it into x minus 3x plus 3. Now my common denominator in this case is just going to be x plus 3 and x minus 3. So what I'm going to do is take each of these fractions and I'm going to multiply by just that, which is x minus 3 times x plus 3. Do the same thing for this one. Do the same thing for this one. Okay, and now watch what happens. My x minus 3 cancels with x minus 3. I'm left with 6 times x plus 3 in the first term. Then there's my equals. Now in this case, my x minus 3, x minus 3, x plus 3, x plus 3, they all cancel out, so I'm just left with 8x. And then in my last term, my x minus 3 and my x plus 3 cancel out. This was x minus 3. So I would have negative 4x times x minus 3, which is left over. Now it's just a matter of simple algebra. I'm going to make sure and distribute there. Here, oh my gosh, look at me. I forgot the 8x squared. Alright, so this will be 4x squared and then plus 12x. I'm sure if I did something wrong, y'all will tell me tomorrow. Let's see, so we can combine these guys. That would be a 4x squared. We can move this 6x to the other side. And we can move this 18 to the other side. Now I'm thinking I want to do that because I can already see I'm going to have to factor. So I know I want that to be equal to 0. So this would be 6x and then minus 18. Alright, a perfect opportunity for us to use some factoring techniques here. The first thing I want to do is factor out a 2 because I see that that's a GCF, and remember that's always the first question. So now I would have that thing. Now let's use our Lizzie method, which you got a review of today in class. But we're going to take a times c, that gives us 18. The factors of 18 that subtract to give me 3. So that's going to be positive 6 and negative 3. And then I have to remember to divide by a. Oh, sorry, which is 2. Divide by 2. And so this would be 3 over 1, and that's positive. Therefore, my answer would look like, this is, the 0 equals 2 is coming from the top, from what I had earlier. And now this will be x plus 3 and 2x minus 3, which again is your Lizzie method. Now what I'm going to do is set each of these things equal to 0. Well, 2 will never be 0. This gives me negative 3. And this one, oops, 2x minus 3 equal to 0. That gives me, if you add 3 and then divide by 2, you get negative 3 halves. So this is a situation where something does not work. If negative 3 was plugged in right there into my function, I would have negative 3 plus 3, which is 0. You can't have a 0 in the denominator. So what I'm going to do is exclude that answer, and my only answer will be this one.